Hello, everyone. I'm Nancy Molenda, Director of Communications for the Aluminum Extruders Council. Welcome to our webinar, Tips for a Successful Design Competition Entry, presented by David Asher of Bunnell Aluminum and Craig Werner of Kaiser Aluminum. Before we begin, I have some announcements. All computer audio and telephone lines are muted, so if you have a question during the webinar, please select Q&A or chat from the toolbar. Type your question in the dialog box, and our presenter will address your questions at the end of the presentation. We are recording this webinar, and we'll send a link once it's posted. Also, the slides for today's webinar are also available now to download on your attendee panel, along with the call for entries for the 2018 design competition. Following our webinar, we will send you an email with a link to a survey about today's presentation. We ask that you take a moment to answer the brief survey. We value your opinions and feedback. Now I'd like to introduce our speakers for today's presentation. David Asher is Process Optimization Manager for Bunnell Aluminum, headquartered in Newnan, Georgia. He has worked in the aluminum extrusion industry for nearly 40 years and has a great deal of experience and knowledge to share with students and educators about the aluminum extrusion process. David is an active member of the Aluminum Extruders Council and has been involved with various committees over the years and is currently a member of our Academic Engagement Committee, as well as a judge for the Aluminum Extrusion Design Competition. Craig Werner is currently Vice President, Extrusion Technology for Kaiser Aluminum. In his role, he applies his extensive knowledge, passion, and leadership to support the company's future growth opportunities. Craig is extremely active with the Aluminum Extruders Council and is a past chairman of the council. He currently chairs the ET Seminar Committee and AEC Business Excellence Steering Committee, and also is a member of the Academic Engagement team. Craig also is a frequent judge for the design competition. Both David and Craig have visited schools giving presentations to further the understanding of aluminum extrusion to students and their instructors. Academic engagement is a passion for both of these gentlemen, as you will soon see. Now it brings me pleasure to turn the presentation over to David Asher, who will start us off. David?
Good afternoon, everybody. This is David Asher with Bunnell Aluminum, the sponsor of the 2018 design competition. And today, along with Craig Werner, we're going to spend the next 35 or so minutes discussing what the competition is all about and how we as an industry can engage with you to come up with designs for the competition that are going to be outstanding designs. So going on to what the objective of our the webinar is today, as soon as I can get the slide to advance. We're going to go into a bit of the background of the design competition, the competition process itself, with some extensive discussion of design tips and what makes for a good design. Craig will be going over that extensively a bit later. What support we have available through the Aluminum Extruders Council, and what the benefits are of the competition to both educators and students. And my slide is not advancing. Bear with me for just a minute. Again, a bit on the value of the competition. Again, aluminum extrusions are, we're part of a growing and in-demand market, in large part because of the sustainability, and practicality of designing with extrusions and the features that can be designed into an extrusion, as well as lightweighting and the resulting environmental impacts that brings about. Again, one of the truly growing markets for extrusions is lightweighting within the transportation sector. Not just because of government-implied CAFE standards for fuel economy improvement, but also because that is where the market is going, where what consumers are looking for. They're looking for, again, more fuel-efficient cars and less of an environmental impact from automobiles and other means of transportation. And again, aluminum and aluminum extrusions are one of the best ways to lightweight automobiles to further achieve those objectives. Another area where extrusions are establishing themselves is in the field of solar energy. Because of the way extrusions can be designed, because of their lightweight, the features that can be incorporated into them, they make a perfect method of creating the support structures for the solar collectors in the solar fields. Still, one of the largest markets for extrusions remains building and construction. They're used extensively, primarily in commercial construction, for all kinds of things, windows and doors, but also for sunshades and for all kinds of other various features and canopies and other things incorporated into building and construction applications. So what is the value of the design competition? Well, it gives us an opportunity to expose students to what extrusions are and understanding more about the extrusion process and how extrusions can and are being used and how they can potentially be used in the future. And it's an outstanding opportunity for students and teachers to present more of the capabilities of the process and to learn more about a process that many folks don't know, haven't a lot about, and haven't been exposed to. So what are the basics of the competition? Well, there's actually two different categories. One is professional for people already in the design industry, and the other is for students. The focus of our discussion today is going to be more on the student competition than the professional. And we're here to talk about two very specific components of the competition. One is the Open Design Challenge, and the other is the Sustainability Design Challenge. And this is open to high schools, colleges, technical schools, as well as postgraduate students throughout the country and the world. Within the competition, we have several financial awards available, including a grand prize, which is open to both students and the professionals. And then within the student competition, we have a first, second, and third place, and then as well as a sustainability award. And we'll talk a bit more about the sustainability award further into the presentation, but that is basically looking at the use of extrusions in areas that help sustain the environment and improve living conditions for people throughout the world. And this year, in addition, the winners will be eligible for complimentary attendance at the Extrusion Design University, which will be in May of 2018 in Chicago, Illinois. And Nancy will briefly discuss that a bit more later in the presentation. So what are the judging criteria for the competition? Well, there's actually four factors that we look at when we're judging. Creativity, as in what's new and innovative about both the extrusion and the extrusion design and the product that's being designed with the extrusions. Practicality, and this is a big criteria, and Craig will be talking a bit more about that as we proceed, but is the extrusion producible? There are limitations on the extrusion process, both in terms of size and complexity of the extrusions. And again, Craig will be talking more about those in just a few moments. And does this design result in a product or a process improvement as compared to other materials and other products already in the market? And lastly, what is the market potential for the product? Certainly some extrusions can be designed that are wonderful designs but have limited market potential. So we're also looking at, does this have a large market potential when the product is designed and taken to the market? The competition deadline for entry is April 2nd of 2018, but entries can be submitted anytime between now and then, with the deadline again being April 2nd. During the month of April, we will be judging. The panel of judges, as Nancy mentioned earlier, has in the past included myself and Craig Werner, as well as others from the industry and academia as well. Winners will be announced on the AEC website, and as mentioned previously, they will come with a complimentary admission to Extrusion Design University in May of 2018. So with that, I am going to turn the presentation over to Craig, who is going to present a lot more details on what makes a good extrusion design.
Thank you, David. Good afternoon, everyone. We're going to talk a bit about the wonders of aluminum extrusion. Shown on the page here is a little graphic that shows a part that's actually used in the solar field, and it's a rather large part. We'll talk about size in a little bit. And it's kind of these yellow parts, yellow with a dark background highlighted. That's what the part is. So the reason I'm showing you this is one of the beautiful things about extrusion is we can put aluminum wherever need be for the design. There are limitations, but we're not stuck with a simple U or C channel or round or square. We can actually put aluminum where it best suits the design needs. There are limitations to that, though. First one would be a circle size limitation. The larger the circle size, which is represented by the circle that could go around the part, the larger this circle size, and this part has a 12.9-inch circle size, that means you need to put it on a pretty large diameter billet. So when you have a larger diameter billet, you need to have a larger press, which costs more, and there's not as many of those available in the world. We'll see that a little bit later. So generally, we're looking for something where the circle size, for the competition, we're looking for a circle size of less than 10 inches. So it's more broadly applicable throughout the industry. More different extruders would be able to handle that. Another limitation on design is the weight per foot. Is the part too heavy? Is the part too light? And we're going to talk a little bit about that in the next slide as well. But in general, parts that are under 8-inch circle size, although we'll take up to 10, and weigh less than 3 pounds per foot, those are parts that are easily extruded by a great variety of different extruders, so that's worthwhile. The next thing is basic shape constraints, and we call them high tongue ratios would be one example of a shape constraint. And this shape actually shows what a tongue is. I'll talk about it a little bit later if I get a moment, but the tongue is this part here, any of these parts, this area is a void that's created, even though it's a solid shape. It's not a hollow profile on the outside, it's a hollow in the middle, but this is kind of a solid channel. In order to create this opening, there has to be a piece of tool steel that goes in there and keeps the metal from flowing into this area. So these are all very easy tongues that you're seeing on this profile. But later we'll see some shapes with some more difficult tongues, and I'll reference those so you understand what I mean. But that's what a tongue is. Finally, somewhat balanced wall thicknesses. Again, this profile has pretty much consistent wall thicknesses throughout, but later you're going to see some parts that have some thick sections and some thinner sections, and we'll talk about why there are advantages to having one or another. A couple of years ago, David and I worked together to put together a chart. It looks a lot more complicated than it really is. All this chart really does, some people talk about weight per foot, which would be on the right here. Some people talk about the area of the part. They're the same, they're interchangeable. So for now, I'm just going to talk about the interplay between circle size of the part and the related press, the related part weight in pounds per foot. And as in most things, green is good and red is bad and yellow is somewhere in the middle. So W means that presses are widely available to make parts that are in this range. So between 1 and 10 inches, between 0.12 pounds per foot, although that's on the light side, but all the way up to 12 pounds a foot if you have a large enough press. So when you're looking at your designs, think about the mins and maxes and make sure that you're in an area that's not red, certainly, because that would make it very difficult and impractical for many extruders to work with. Not impossible, but impractical. The beauty of the aluminum extrusion process, and you're seeing a couple cooler pictures here, is, again, we can put metal where we want. And a lot of times adding extra features in isn't difficult, because it's just a matter of creating a die to put all the little heat sinks in or put in the screw bosses. So if you look about it on the web about aluminum extrusions, you'll see many, many different designs for aesthetic, structural, or other purposes. The beauty of extrusion is, besides extruding it in the 2D and making it out into a 3D shape, we can also fabricate and finish aluminum extrusions very easily. So we can further enhance the value to the end product use by doing that. Extrusions come in different alloys and tempers. The alloy refers to the chemical composition that makes up the material, all the way from very pure aluminum, mostly the 1000 series, through different alloy ingredients, be it copper, manganese, silicon, magnesium, or the most popular and the broadest applied class of alloys is the 6000 series, which is a combination of magnesium and silicon. It's a great choice because it mixes both strength, corrosion resistance, machinability, weldability, formability, and it's heat treatable. So we're not going to make you experts in this short presentation, but there's a number of different alloys for different purposes, and those alloys can be further adapted by the way that they're thermally treated, which is the temper shown on the right. Again, I'm not going to take us through all those as examples, but the material itself can be modified, as well as putting the material where we want in the profile. So when you look at some of those different alloys in the 6000 series, which is what we're focusing on in this slide, typically we get increasing strength as we go up and to the right. So the more mag and the more silicon we have, the more strength we have. The alloy series tend to overlap somewhat. So even though you might be looking at a 6005 alloy, there are parts of the chemistry where it would overlap with 6063. But in general, just think of it as the more mag silicide, the more strength. Now we're going to talk about different types of shapes, and this becomes important because it deals with how things might be tooled and the complication of that. Many shapes are solid. It could be a rod or a bar, a round piece, a square. This is a fairly simple, solid shape that we're able to extrude. Another would be hollows. So hollows, somebody else is moving the mouse around, sorry. Hollows can be different classes, but for now, let's just think of them as very simple. There's a hollow, there's material, and there's a space in the middle of it. And a much more complex hollow, this one isn't terribly complex, but would be a multi-void hollow, where you have, this has one void, this one has 1, 2, 3 voids. So as you do that, it gets more complex. In between those two is what we call a semi-hollow. And this is actually a solid shape. You don't see any contained hollow section in the middle. But this is a good example of the tongue ratio, because again, the tongue is required to hold back this material so that this void in here is formed. And the steel tongue is supported by this narrow little opening. The tonnage that's required of the press pushing the solid aluminum, because it's not molten at the time this is formed, through the die is pushing on this area. And when this tongue gets too narrow here, it's really the ratio of this area to the width of the opening here. So we're looking at the piece of steel if it's going to be too fragile. So that's what a tongue is. And that's an example of a more difficult tongue ratio than what we showed you earlier. Here's a couple simple design practices, and these are very carefully worded. You know, they say not this, but this. But the reality is you can do all the things that are on here. So we can easily make a part on the left that has a thin bottom wall and the two vertical walls of the C-channel are thicker. That can be done. It takes more metal because you're obviously filling that in, but if all you really need is this edge to be defined, the shape will be lighter and cost less because there'll be less metal in it if we do it like this. In addition, it's easier to extrude because there's more consistency in wall thicknesses, which is one of the things I noted on an earlier slide. If you're going to make some kind of a heat sink looking part with two voids in the middle, while you might be able to save a little bit of money on metal by making this wall thinner, again, it's better to have it balanced. It'll be easier for the extruder to flow metal into there. They'll be able to make this at a higher productivity and maybe a lower scrap rate than they would this. So it's better to design with this, but if this is critically necessary for design, that can be done as well. While you can put sharp corners in dies, in profile designs and the associated dies, it's generally better where possible to put in rounder corners. Again, it extrudes a little bit better, a little bit less scrap, a little bit faster extrusion. This combines a few of those things. This is showing a sharp corner here versus a gentle corner. And is also showing, hey, we're able to maybe reduce the wall thickness and put a little blip on the end here if we need it. Sometimes making parts that are not very symmetrical always is extrudable. We can almost always extrude a part, but it might cool a little bit funny on the table, might require a little bit more stretching. It's better if we can have a more symmetrical part. And I'd say the final thing, and what people don't think of often, is they think of just the flat surface. But a lot of times when you extrude a part, you kind of get a mark on the opposite. If this top surface is flat, you get a mark from the parts on the other side, just a little shadow looking, perhaps when it goes through painting or when it goes through anodizing. Sometimes you can build in very nice decorative features into an extrusion for no additional cost, which also completely hides any of that shadowing that may occur. Some more things to look at would be these dies. So if we look at the one on the left, if there's no reason for this part to have 1, 2, 3 different hollows, we're better making it as a single hollow rather than a multi-void hollow. It'll be less expensive to tool and it'll perform better. It'll be easier to extrude. If, however, the design requires maybe there has to be some material flows through here and a different material through here and it can't be open to this, can always do a part like this, but we're better making it as a single void rather than a 3-void hollow, and also better having the rounded corners that we show there. These parts show a screw boss that's put onto it. If there was going to be an end plate attached to this, often screw bosses are designed in. Self-tapping screws can then tap in and hold something onto the end. That comes in again on this shape on the right. This is a very similar shape when you look at it. There's only one small difference, which is this wall going across here. If we get rid of that wall, if we can put the same screw boss on this wall, we go from a single void hollow to a double void hollow. So we're better staying with the single void hollow. So these are just some practical design tips when you're thinking through your designs for the competition. The more of these things you take into account, the better your design will be acceptable. Although, if needed, we can do the things that we talk about that, we'd rather you not do that. We can certainly do it. The extruders can do that. This design tip is just talking about that screw boss we referenced earlier. And, the first inclination, if somebody's thinking about using the self-tapping screw, is always to do a perfectly round hole. But that turns this part into a 2-void hollow, which is going to extrude much slower, be much more expensive to tool. Where a part like this is a simple hollow shape with not too bad a tongue ratio and still performs the same function of having screw bosses built into it. Finally, sometimes complex hollows can be, if it works for the application, can be better designed as 2 different parts combined. So we have 2 single void hollows, the brown one and the blue one, which is creating the equivalent of a 1, 2, 3, 4, 5, 6, 7, 8. So mini void hollow. So sometimes you can make mating parts that fit together very well. And that's actually one of the advantages of aluminum extrusion, is besides the extrusion and the fabrication, the finishing you can do, it's often very easy to build in mating parts. So those are just some practical design tips. David's going to talk to you a bit more in a moment about some of the other ways that we can work together and how we can ensure that the things that you're working on, the ideas you have, can be properly thought out. So I'm going to turn it back over to David now and let him take on from here. David, you may still be muted.
You're correct. I'm sorry. One of the objectives of the Aluminum Extruders Council is for us, the membership of the AEC, to engage with instructors and students firsthand. Now, certainly the competition is open to anyone. It's an open competition. But again, we would very much like the opportunity to engage directly with you as both instructors and students to help you better understand our processes. And our membership is scattered all over North America. We generally have someone close to most every university in the country, and we can engage both online and face-to-face. The Extruders Council also has lots of information available on the website. We'll get into a bit more on that in a bit, where you can learn more about some of the things that Craig has gone over, as well as see lots and lots of examples. Again, we love to have the opportunity to come into the classroom with sample extrusions for kind of a hands-on presentation. And again, as mentioned earlier, we do have membership all over the country, and we're generally available for plant tours to learn more about the process. Again, we can do virtual tours, we can do physical tours. Again, we have information available, and we're ready and willing to engage in any classroom setting where we have an opportunity to help expand your knowledge of our processes. Again, this is an opportunity to engage with an industry, a growing industry, and an industry that's got lots and lots of opportunities, as mentioned earlier, in industries such as transportation. It's also, the competition is a wonderful way for students and teachers to participate in like a senior design project, or not necessarily even a senior design project, just a design project within the classroom. The entries can be submitted, and there is a potential for a financial reward for the engagement. And again, this sort of competition, at least from our past experience, is one of the things that students really seem to enjoy doing, and it's an engaging activity for them. And certainly for the students, there is an opportunity to win a fairly significant amount of money. And one of the other big benefits for students, it's an opportunity to meet with industry professionals, again, in an industry that hopefully will be an area where some of these students would eventually potentially want to go to work. And again, get a firsthand opportunity to meet some of these professionals and get exposure to it. What's on the screen now is the winner of the competition from 2017. This was a student at Purdue University in an industrial design class who designed a innovative rack for bicycles. And that what was so nice about it is he incorporated many of the design features that Craig was talking about earlier into his extrusions to come up with a unique and innovative new design for a bike rack. Moving on to our sustainability competition and why that is a bit different from the open competition. Again, the focus of the Sustainability Award, as we discussed earlier, is to do something to address societal and or environmental challenges. At the bottom of the screen, you can see some entries from prior sustainability competitions, including a solar water purification system, as well as some temporary structures. Again, this was a very unique design in terms of temporary structures that could be set up very quickly in the case of like our recent hurricane damage in Puerto Rico and elsewhere. This type of structure can be put up very quickly to provide temporary housing and shelter for people who have lost their housing. So what are the next steps? Well, the next step is to visit the ET Design Foundation website and or the Aluminum Extruders Council website to learn more. And Nancy will now discuss a bit more on next steps. Nancy, are you there?
I'm here, sorry. Thanks, David, and thanks, Craig. So, yeah, if you want to, if you're interested in the design competition, I said at the beginning that in your attendee panel, besides the slideshow for today, we also have the call for entries that you can download. You can also get that at our website at etfdesign.org. That's a direct page to our design competition page on the AEC website. And there you'll find all the information that David went over about the design competition, and also within that site, all the information that Craig talked about. You'll find a wealth of resources on our website. So with that, let's see if we have any questions from our audience. And I will remind you that if you do have a question, please use the Q&A or chat from the toolbar on your screen and type in your question in the dialog box. So we do have one question, and this is probably for Craig. So Craig, when you were talking about constraints, you mentioned tongue ratio. Can you say more? What exactly is that, and how does it limit the design?
No, I covered that a bit. Let me go up a few pages and find the tongues again. Find something. Well, let's just use this one. So a tongue ratio again it's defined as the area of the void in the semi-hollow divided by the width of the gap squared. So typically, if you had let's say you had 1 square inch of material here, and you had a quarter of an inch between here and here, just as an example. Well, that would be like 1 divided by 16. So that'd be a pretty, or 1/16. So that'd be a very high tongue ratio. Whereas if these little legs here weren't here, you'd have 1 square inch divided by 1 inch. So maybe you would have a 1-to-1. It'd be an easy tongue. Typically, if tongues are 3-to-1 or less, it's very easy. It's not even really considered a difficult tongue. People can do 4, 5, 6, 8 tongue ratios or much higher. But often to do that, you need to go hotter and slower, and you lose productivity and recovery, and you have issues, perhaps mostly production and cost issues. The costs go up a lot. The tooling is more expensive. So typically, if you can avoid big open areas with little skinny places that are holding the steel tongue back, that's to your benefit in the design world.
Okay, thanks, Craig. And we have one more question. I heard practicality is one of the judging criteria. What are you looking for, and how do you assess practicality?
Can I start with that one? So, I mean, I think I covered a couple of these things. When we're looking at the overall design, I mean, the circle size, and, you know, we kind of gave you a good hint for the practicality. 10 inches or less than 10 inches is all we're going to accept for this particular competition, although you can make parts larger than that. There's not as many extruders that can do this. 8 inches, there's a lot of extruders, so this will be in the sweet spot, something with a circle size of under 8 inches. You don't want things that are too heavy or too thin-walled that would be difficult to extrude, or tongue ratio. So all these things from a practicality viewpoint come into it, as do some of the other things I mentioned. Hang on a second, I'm not having any luck clicking. So somebody's moving thank you. You're taking control away from me when you're doing that. There we go. Some of the other things would be some of these hints here. Again, asymmetrical parts are very easy to produce, but if they can be made a bit more symmetrical, they're better. But often if you need the asymmetry, no problem. So it's kind of paying attention to some of the design tips that we've noted here will help you to come up with the design that's the most practical. But that only deals with the production practicality. David, maybe you want to talk about some other elements of that.
Well, yeah, Craig, and I do want to reemphasize one point that you made, and that's actually incorporated in the brochure that is downloaded for the entry form, and that's the circle size. That's a concept that is probably a bit new to many folks in terms of what that really means. But on the brochure that's downloaded for entry, there is a shaded circle that is that 10-inch circle, Craig, that you mentioned. And again, if the extrusion that you design won't fit within that circle when it's set on its edge, then it's not a design that's going to meet the practicality criteria that we discussed. But all the design tips that you have covered off, this is getting into a practical extrusion design. And then extending on from that just a bit, certainly practicality does reach over into what is the product itself, and we're kind of moving into some of the other criteria, such as commercialization. I mean, designing a practical extrusion also has to go into a practical product, which it has some real market potential in the marketplace. Something that someone would find usable and useful in their day-to-day life.
All right, great. Thank you, Craig. And David, I'm going to go down to the end of our presentation here real quick. So let me just say thank you again to both our speakers, David and Craig, for a great presentation and sharing this information with us. And thanks to Bonnell Aluminum for sponsoring the 2018 Aluminum Extrusion Design Competition, and to all of our members for their time, commitment, and involvement in the AEC Academic Engagement Initiative. The recording for today's webinar will be available online soon on the AEC website, and we will send you a link once it's uploaded. The evaluation survey for this webinar will be sent to you following this presentation, and please share your comments with us. Your input is very valuable and helpful in developing future webinars. And as Craig and David mentioned, be sure to visit our website for more information on upcoming webinars on aluminum extrusions, and also on information and resources on aluminum extrusion design, applications, technical information, and more. And one more thing, excuse me, we mentioned earlier about the Extrusion Design University. It's a new event focused on expanding knowledge about aluminum extrusion design, applications, and technology, with more than 20 educational sessions and an expo. You can find more information about that event at aec.org/edu18. So with that, we will end our webinar, and thank you for being with us today, and have a great rest of your afternoon.